Thank you very much. So, look, thanks for coming along today. Firstly, I'd like to say it's very good to have a small audience. Much appreciated. Secondly, I'd like to say how pleasant it is up here on the stage. It's padded, nice carpet and things like that. So look, I really don't like the name of this talk, but I couldn't think of anything else at the time. I was in a hurry, but we'll see how it goes, and hopefully it sort of makes sense. So I was sitting at home minding my own business back in June, and I got a message from Francesco from Erlang Solutions, who I'm sure you all know and love, wishing me a happy birthday. It's very nice of him. I must have been somewhat intoxicated at the time, and I mentioned that I would be in Berlin. I was just planning to come across for the MQ Summit and not really do anything else. Next thing you know, Francesco's convinced me in a few lines that I need to do a talk at CodeBeam as well. And as you can see from there, the topic he wanted me to talk about is bringing the beam to mainframe environments. So what's the connection, I hear you ask? Well, for my sins for many years, I wouldn't say I've been a mainframe developer, but I've worked on the fringes of that, and I've worked with mainframe-like operating systems, and in particular, the OpenVMS operating system. So anyone here familiar with OpenVMS? Even heard of it? I'm glad some people have heard of it. If you were familiar with it, I'd suggest counselling. But anyway, I've worked with VMS one way or another on and off for decades. In fact, since probably about 1992 or something like that. And I've dabbled in, and I would say quite successfully, porting Erlang to run on OpenVMS. So Francesco's vision here is, Brett, you know how to port Erlang to alien environments, tell people about it, and maybe we can do something to see about, helping these people who are quite keen and enthusiastic about getting Erlang running on IBM mainframes and such systems. So I'm not sure how interesting all of this will be to many of you, but we'll see how we go, and I'll try and come up with some silly jokes along the way. But before we do that, just some numbers. It's interesting having bar discussions with various people and talk about the old days, because that's what you do when you get to my age. You just reminisce. But just looking at the numbers, IBM mainframes and the like run many of our larger financial institutions. There's a disturbingly large amount of financial processing still happens on these systems. They are not going away anytime quick. But one of the things that is going away are the people that actually know how to write code on these down systems. You've got billions and billions of lines of COBOL code that is doing financial transactions on a daily basis, processing your money, my money, everybody's money. I've put 21C CSVSE there. The investor that I work for has acquired that particular mainframe operating system off of IBM. Doesn't have a massive number of customers, but the customers it does have do an awful lot of high-value transactions. So looking at some more numbers here, and it starts to get a little bit scary. This is something I copied from Twitter some time ago because it caught my attention and I kept it. And it's basically saying that every day, literally trillions of dollars worth of transactions are handled by systems that are written in COBOL. These are running in mainframe environments. Okay. Now, getting back to Francesco's desire, wish, whatever, and my comment about the fact that the people that know how to develop these applications are retiring. What do you do? How can you modernize these environments? Well, if you can provide more modern and interesting tools that the younger guys want to play around with in those environments, that's a bit of a start. It seems that there is interest in Erlang. I mean, you've already got Java, OpenJDK at least, running in IBM mainframes, myriad of other open source technologies. So why on earth not get Erlang running there, and along with it, Elixir, Gleam, the rest of the Erlang ecosystem. That could be quite fun. A little bit of background on me before we start getting into the boring stuff. My journey with regards to Erlang began specifically the 4th of November 2008. I was working just out of Sacramento with my good friend Chris Brown, who's pictured there, and I asked his permission for the picture, and he gladly accepted. And he's responsible for this diagram as well. On the next slide, you'll see that Chris and I were both working for HP's OpenVMS group at the time. We were visiting customers in California, and we were having various discussions about how we could modernize the VMS environment, introducing new technologies, particularly around message queuing and so forth, which I'll come to very shortly. But this diagram here was kind of how it all started, and I won't go through it all because it was a very, very long day, I can assure you, and the comment over there in the yellow kind of sums it up. we did not have a great day. We thought we'd go into Sacramento, have a nice pleasant dinner, and then head home again, only to encounter drug dealers, pimps, what I would assume were hillbillies carrying guns on the back of a ute. The train didn't take us all the way back to where we needed to go, but the pimp offered his assistance, which we really didn't want. And eventually we made our way back to our hotel, which was like a sigh of relief, so we just hit the bar, and that was it. And while we were sitting at the bar, we started having these discussions. You know, what can we do to modernize the OpenVMS ecosystem? And I've been doing message queuing forever, so one of the things I'd been discussing with Chris was, can we do an AMQP implementation? I'd worked with an old friend, Peter Hinchins, who started off doing OpenAMQ, the very first AMQP implementation, Advanced Message Queuing Protocol. Peter had pulled out of the AMQP working group. What do we do now? You know, we need some supported software here. And I discovered this thing called RabbitMQ, which looked kind of cool, but it was written in this crazy language called Erlang. And in a semi-intoxicated state, although possibly we'd gone a bit further than that by this stage, but Chris basically dared me to port Erlang to OpenVMS. So, you know, how hard could it be? This seemed like a really good idea at the time. The world changes. HP had a restructure. Chris left the company, still in close contact with him on a regular basis. And I changed roles as well. Because of the knowledge I had acquired of RabbitMQ, I ended up as part of HP's rather short-lived cloud services team supporting Rabbit, which provided the nervous system really within the OpenStack environment. So I jumped out of the OpenVMS world and into the other extreme cloud, bleeding-edge stuff. A few years later, in 2013, ironically on my birthday, as it happens, a lot of things seem to happen on my birthday. June the 5th, 2013, HP pulled the plug on the OpenVMS operating system. About a year later, our investor, who owns the VSE operating system I mentioned before, acquired the rights, exclusive rights to the VMS operating system, and I got offered a job with those guys, which is what I've been doing ever since, really working with customers, doing what I always used to do, helping them to modernize their legacy application environments, integrate them with other things, and so on and so forth. Rabbit continues to play a pretty big part of my life, and obviously a bit of Erlang consulting and so forth thrown in. But for my sins, I suppose I've learnt more than I really want to know about the inner workings of the beam in particular. I could not claim to be an expert by any stretch of the imagination, so I'm not going to do some deep dive into it, but you know, I've lifted the covers, I've had a look at what's there. In terms of code, you actually get pretty good bangs per buck, good value for money with Erlang and the beam. It's about 480,000 lines of C code. Around 2020, some C++ was introduced for the just-in-time compilation, and there's about 2.2 million lines of actual Erlang code that make up OTP. There's obviously build scripts and things like that. Now, the C code itself is actually very well written, no surprises there. And because Erlang has been ported to different flavors of Linux, different flavors of Unix, there are different features that you may or may not want to include in a beam for various reasons. There's something like about 900 unique macros, assuming you understand the basics of C programming at least. There are like 900 unique macros that define what gets included in the beam, what doesn't get included, what gets built, what doesn't get built, addresses platform dependencies, and so on and so forth. But as I say, fundamentally, you've got some well-written C code here, and it's definitely not the worst thing I'd ever tried porting. Okay. And just for comparison, in addition to having ported Erlang to OpenVMS, we've never released it, there's still some work to do, so don't get all excited and go out and buy VMS systems tomorrow. But I've also ported OpenJDK to OpenVMS, and I still have nightmares about that experience. Fundamentally, you get far more bangs per buck with Erlang OTP than you do with Java, in my personal opinion. It's small, concise, well-contained, and it works really, really well, as we all know. So, how many of you here have built Erlang from source? A good number. Okay, so you know that it's a relatively painless process, right? You've got a good Linux distribution, you've got a sensible C compiler, GCC, Clang, whatever, you've got all the bits and pieces that you would expect to find on any Linux distribution or can soon get. All up, you can build Erlang probably in under 10 minutes, right? The box up there is basically straight off the README off GitHub, just a few commands, bam, you've got a working Erlang installation. Very, very straightforward. The only minor complications or considerations might be, well, you know, what features do I want to include or exclude? Where do I want to install it? What level of optimization do I want with the compiler and things like that? You don't need to worry about that. You can just build it and it'll work. It's basically what you get is typically good enough for most purposes. That's fine. So, like I say, pretty much any half-decent, self-respecting Linux or Windows implementation and some rather interesting Unix implementations, you can quite easily build Erlang OTP. And I've just listed here some of the platforms, probably not all of them, but commonly used platforms with Erlang today. Out to the side there, you'll see I've mentioned HPUX, True64, and AIX. You may not have, anyone heard of True64? Gotcha. So this was a failed attempt by Digital Equipment Corporation to provide a Unix implementation. It was actually the first 64-bit version of Unix. Actually very, very nice, but it didn't take off, which is a little bit sad. But for something to do one day, I did actually port Erlang to True64. HPUX will crop up in some of the subsequent slides. AIX, I have mixed feelings, mixed emotions about AIX as a Unix implementation, but you can build Erlang fairly easily on that as well. So, why not also go and build it on these other platforms, which is, you know, what Francesco was asking about. So the case study really is the work I've done on VMS and some of the things I've found. So if you have a spare mainframe and have the inclination, maybe you'll get a few pointers in these next few slides. But essentially, the flow diagram over the far side there is the sort of process that I typically take when porting these large open source applications to VMS. It can be a complex process, and as I say there, I have certainly felt the pain. You start off with high expectations and you have a bit of a poke around in the code, we call that exploration, and then you kind of have a little bit of insight and you start ripping into it, and then you get all excited and just go for broke and have a mad frantic hackathon and actually get something working. Like I remember OpenJDK on OpenVMS, I got Hello World working and I was really, really pleased with myself. And then I did something else and it all just blew up in my face. And that's when you enter the realm of systematic drudgery, where you actually have to start at this end and work your way through until it all works. Go round and round in circles until it's done. But the sorts of things that you need to consider, I've listed them there, you know, architectural differences. There can be a myriad of these. Could be the CPU architecture that's a problem. Could be support for multi-threading, things like that. Just different behavioral characteristics of the operating system. Real-time versus non-real-time, for example. You know, what functions does the operating system actually provide in terms of system calls? And file systems can actually be a real pain in the butt. You know, different path delimiters, things like that can actually cause more trouble than you really care to think about. And VMS is totally different to Unix or Windows with regards to, you know, file specifications and so forth. Equally as importantly, do you actually have the build tools, right? To build Erlang on Linux, just need a half-decent Linux implementation, GCC, whatever, make. What say you're in some strange alien universe where these things don't exist? What do you do? So, just very, very briefly, and then we'll start getting into the gory details of some of them at least. I mean, OpenVMS has been around since 1977, originated with Digital Equipment Corporation, who were acquired by Compaq, who were acquired by HP, and now, as I say, it's owned by our investor. It's not at all Unix-like, it's very proprietary. Back in the day, it was considered very secure and very stable with legendary uptimes. A lot of this was that VMS, much like Erlang, has a built-in clustering capability. But it's a different mindset to Erlang, you know, whereas Erlang has the kind of shared nothing thing going on, VMS kind of takes the other view from a clustering perspective. So there are similarities and differences. There is still to this day a substantial and loyal installed base, and you know, we've managed to craft quite a good business out of since we've taken over the operating system. no particular one sector, across the board, still quite big in financial services, still quite big in government and military, and things like that. So with that background, and we're going to try porting Erlang to this environment, what have we actually got to build? Okay, obviously the main thing we've got to build is the beam. That's the big challenging bit. There are a few other executables lurking around, the endpoint mapper daemon, the Erlang compiler, sundry other bits and pieces that are required to get a runnable environment essentially. There's a few shared libraries associated with NIFs and drivers, if you want to build in OpenSSL support and so forth. They're the main components. Erlang itself, you almost don't have to worry about. You could compile the Erlang code on any platform because the compiled Erlang is much like Java. It's totally portable, within reason. This was a diagram, and you won't be able to read it, and don't bother trying, but this was a diagram I actually prepared a few years ago to actually illustrate to some of my OpenVMS friends the pain and suffering I was going through in terms of actually trying to get Erlang working on OpenVMS. And whilst you can't read it, there's a lot of boxes there, and each one of those boxes describes a problem. The problem might be that I need some open source library on OpenVMS, maybe just zlib for compression or libreadme or something, trivial like that, no big deal. All the way through to missing functions in the C runtime library that are deficiencies on OpenVMS. We don't have them, or maybe we didn't have them. And differences in behavior. So for example, one of the things there describes the fact that the poll and select functions, which you use for, say polling a socket or whatever, on Unix it doesn't care whether it's a socket or a file, or you can use poll and select. On OpenVMS that will only work with sockets. So there are all these sorts of things that need to be taken into consideration. Look at some of them in a little bit more detail in the next slide, but this just kind of elaborates on what I've been saying. You've suddenly put all this Erlang code onto OpenVMS. This is an alien environment for the Erlang code. How do I build this darn thing? Even what options do I specify? What characteristics does VMS support? What characteristics does it not support? I've got to think about, as I said before, threading, inline assembly code. There's not really too much of that in Erlang per se. Polling I talked about, and I mentioned file systems before. That can be a real nightmare on OpenVMS. Ultimately, what you want to make your life easy is a high level of POSIX compatibility. And OpenVMS is not at all UNIX-like. It has, I would say, in the grand scheme of things, a fairly low level of POSIX compatibility. Only within the past 3-4 years did we actually get C99 compatibility for the C compiler and runtime. And we have a tool called GNV, which stands for GNU's Not VMS, which provides a fairly average bash shell and several utilities. But there is no way on this earth that the state of GNV at the moment is good enough to build something like Erlang OTP. It's not going to happen. So we don't panic. Okay. What do? The approach I tend to take, because I'm a fairly simple person at heart, is essentially a brute force one. What I do and what I have done in this particular case is to build Erlang on a supported platform, Linux box, whatever, capture the output of that build and essentially transform that log, if you like, of the build instructions into something that will work on OpenVMS, right, using the tools that OpenVMS provides. Like I said before, you also have to go through the config.h, which is the header file generated by the configure procedure that says what's in scope, what's out of scope, essentially, and make some adjustments to that appropriate to the target operating system, in this case VMS. Okay. A few of the more basic matters. So one that always comes up when you're porting open source to the VMS operating system, and indeed to an IBM Z mainframe, is that there is no UNIX-like fork function. It doesn't exist, and it possibly never will do on OpenVMS, despite it's something that we just keep revisiting, and we just haven't come up with a good way of doing it yet. It's, is it justified? We're not sure. The good thing about the Erlang code is that the number of fork calls is actually very, very small. If you think about it logically, that it's not really something you would expect the beam to be doing anyway. And essentially what they are basically just fork exec sequences that start some other program. So that can be easily dealt with, as I've described there. OpenVMS C runtime library, mainframe runtime libraries actually have different characteristics from Linux from each other. For example, I've cited one there. I can't use the fcntl C runtime library function to toggle sockets from blocking to non-blocking. I need to use ioctl instead. Same on Windows. Our latest C99 enhancements to the runtime library have rectified that and the subsequent point about select and poll. But these are the sorts of things that you need to consider. And I think in order to get Erlang working on OpenVMS, all up there are around about 100 modifications to conditional compilation and also some hackery to create, I suppose, what you would call them, just implementations of functions or functionality that did not exist from an OpenVMS perspective. Beam makes, as I'm sure you appreciate, considerable use of threads for things like schedulers and asynchronous thread pull. And for the most part, much to my amazement, I was expecting this to be a nightmare of an area to deal with. It actually went through very, very cleanly. And I suspect that would be the case in the mainframe environments as well. There are some functional differences, one or two missing functions, but really nothing too drastic. The one that did catch me out for a little while is the default thread stack size, which on OpenVMS for some reason is pathetically low. But obviously, the guys at Ericsson have encountered that particular issue before, and there's a macro you can define at build time which sets the default that's used when threads are created to a more appropriate value. Just-in-time compilation, this is a work in progress. I'm still looking at that. The just-in-time compilation was introduced in Erlang OTP 24, so still fairly new, I think 2020. And it's really quite clever. But, you know, porting that to certain operating systems or different architectures, I mean, so OpenVMS started its life on the VAX architecture, then it went to the Alpha architecture, then it went to the Itanium architecture. There was a brilliant idea. And now we've ported it to x86. So I can get this just-in-time ASM thing, I think, working quite happily with OpenVMS on x86, and that's probably going to be a hobby project when I get back home. But you don't need to build in just-in-time compiler support, right? You can, say, configure disable JIT. That's fine. And you'll still be able to run most Erlang applications, of course. Some of them might just not be quite as fast or whatever. But for some architectures, the just-in-time compilation could be a sticking point in terms of porting Erlang completely. You probably won't be, oh, you can read some of it. Like I mentioned before, it's not just necessary to make changes to the C code. You also, more often than not, are going to have to make changes to some of the Erlang code. If you actually have a look through the OTP code, there's a reasonably frequent usage of things like OS type and OS command, and there'll be things like the case statement I've got there, where you're checking for, you know, what the operating system is and what particular version of that it is, you know, some Linux variant or whatever, and taking some action, returning some value based on whatever that is. So if you're porting Erlang to a new operating system, you need to take this into consideration. And likewise with OS command, which is running an operating system command, there is code in OTP that runs operating system commands. That's not going to work on OpenVMS because it's never seen OpenVMS before, right? So, as I say, in addition to making changes to the C code, you also need to make changes in a number of areas within the OTP code itself. This is maybe a little bit difficult to read, it's not too bad, but just elaborating on that, OS type expects the return type to be an atom. And interestingly, on the HP-UX operating system, it tries to return HP-UX, which as far as Erlang is concerned is not an atom. So that's a rather, you know, when I was building OTP, Erlang OTP on HP-UX, that was a rather interesting little discovery. Very, very easy to fix, but interesting wee anomaly. CPU and topology. Like I said, in terms of threading and things like that, OpenVMS is pretty good, and it also provides these system calls, the sysconf calls that I've listed there, described there, to actually figure out what the CPU topology is. You know, how many processes are there, how many are online, etc., etc. That's great. Again, with reference to HP-UX, nope. It's got a completely different API. Right? So there are things like this that pop up all the time that you sort of don't expect. This one was really weird, to do with memory map files. Again, an HPUX issue, where there are two macros that there's map underscore anon and map underscore anonymous. Most operating systems have both of them, and they've both got the same value. HPUX has only one of the darn things, and that causes some grief in the Erlang code when you try and compile. Trivial to fix. Probably should tell Ericsson about it, and they can fix it in the next release. It's kind of a no-brainer. Another thing you want to try and do, I think, when you're porting Erlang or indeed anything else to a foreign world is to try and limit the amount of change you have to make. Certainly, get something up and running and take it from there, right? So in the first instance, try and limit the amount of change. So in that sense, what I did was, I basically, as far as Erlang is concerned, OpenVMS is just another variant of Unix, which in reality it most definitely is not. But by tricking Erlang into that belief, that greatly minimized the number of changes that I have to make to some of the OTP code. The rest of this slide really is just an illustration of some of the multi-core stuff where I did a little simulation using about 100 million samples running on 8 cores on a VMS system to do a Monte Carlo calculation of the value of pi. And the graphic down the bottom, you can see this is 774% of the CPU is being used, so it's using it's using the full 8 cores, which is exactly what I want. So the darn thing is working, right? It's good. So where am I at? I've got this working. I'm quite excited about actually getting it working a lot better on OpenVMS x86. There's a few hacks that I've got in there that I want to eliminate. I haven't got full 64-bit pointer support in there yet. VMS supports both 32-bit and 64-bit pointers, and there's a lot of fun and games with that. But it is sufficient, what I've got there at the moment, it's sufficient to run some older versions of Rabbit. It'll run yours, run a few other applications. Almost runs Elixir. I've got some work to do there. And per the previous slide, multiple cores and so forth working well. I would describe the performance as average. And there are probably some fairly major contributing factors to that. I've got some grubby hacks in there around poll and select. So if you look at that graph there, which is publish rate for publishing messages into RabbitMQ running on OpenVMS, it's pretty poor when you compare it to, say, even a fairly small Linux system. I would expect to be well up in the tens of thousands on even a relatively lowly powered Linux system. So we've got some performance issues that we need to figure out. So, okay, that's VMS, but what about mainframes, right? What about ZOS? What about VSE, things like that? Well, I need to have a chat with our investor. I think he has some interest in this. He's certainly well aware of Erlang, and, well, being Swedish. And I've just listed some of his companies there, TerraCloud and 21st Century. We do a whole range of things, but the focus for the 21st Century guys is definitely in the mainframe space. So we can explore what may or may not be possible there. From a technical perspective, I don't actually see any impediment to getting Erlang working on something like ZOS. There are a number of reasons for that. One of them is, as I've listed there, ZOS provides Unix system services. So it basically has, I suppose you would call it a compatibility layer. And there's also Linux on IBM Z. And that might be more readily tractable, but it's probably not really the same as using ZOS with the Unix system services. But one way or another, I think this is eminently doable. So like I say, these Unix system services, they've actually been around for a long time, since the late 90s. And they provide essentially a POSIX-like compatibility layer, which will address, I would imagine, I would actually say that OpenVMS, for various reasons, is possibly a worst case. I actually think that ZOS with something like Unix system services is probably going to be easier. I think you've got a better level of POSIX compliance going on here. You've got more of the Linux-like tools that you would need, to, like you would normally use to build Erlang and OTP. So I think the probability of success is fairly high. And there's actually plenty of stuff out there on the internet. If you have a poke around GitHub, some of the sites I've listed there, you will find that there are hundreds of repositories with open source software ranging from things like OpenJDK all the way up, and Redis and a myriad of other things. So if these things can be made to work on a mainframe, I'm pretty much 100% sure we can do the same with Erlang OTP. So in summary, and you shouldn't forget this, it always fascinates me when people are talking about their favorite language like Java or Erlang or Python or Ruby. Under the hood, there's a whole pile of really smart C code that some really smart people wrote years ago that's actually powering those things, okay? Don't forget that. And all credit to those people. There's, whilst I am no fan of having ported OpenJDK to OpenVMS, I'll take my hat off to the guys that implemented the JVM. There's some very good code there, and similarly with Erlang and the Beam. That's some absolutely fantastic work. Like I said, it's not just a case of porting that C code, however. You also have to look at, in the case of Erlang, the Erlang OTP code. You may have to make changes to applications. So I actually had to make changes to RabbitMQ because, it does some OS type and some OS command calls and things like that. You need to think about all of these things. As long as you've got a reasonable level of POSIX compliance, as I say, I think you've got a pretty darn good shot of building Erlang OTP pretty much anywhere. But it's not a small project, and it shouldn't be taken lightly. Dealing with just-in-time compilation could prove to be the biggest challenge. You might need help from a compiler guy or something like that to deal with that. I think there's reasonable alignment, shall we say, between the strengths of Erlang and mainframe characteristics like high availability, fault tolerance, and concurrency. And I think those synergies, could really be leveraged to benefit both Erlang and the mainframe and ecosystem. Kind of a symbiotic relationship, I suppose. As I've said there, introducing languages such as Elixir and Gleam will help to modernize the mainframe environment and help people who have those environments to employ younger people and keep them interested in doing cool stuff. And, as I say, these things aren't small projects, and it does tend to be an iterative process. Tends to be some pain and suffering along the way, but it's great fun, and I quite enjoy it. Just a little blurb there from Joe Armstrong talking about parallelism and things like that, which is possibly not too relevant to what I'm talking about, but it just caught my attention at the time, so it filled a space on the slide. And really just a few words, which I'm sure I've already said to conclude. As I say, probably no big deal if you've got a reasonably POSIX compliant environment to building Erlang within that environment. SMP can be a bit of a challenge, just-in-time compilation can be a challenge, things like that. You're probably, like I keep saying repeatedly, you're going to have to do some work on the actual Erlang OTP code and potentially your existing Erlang applications for sure. But I think it would be somewhat symbiotic for the mainframe environment and for the Erlang community if we could get something like this working. And with that, any questions?
It was amazing, Brett. Thank you so much. There's the first question. And also you can post online using Swapcard. I'm going to check that in a second.
So really nice presentation, reminding me of my university courses. So I actually studied a little bit of VMS at the university. So as far as I remember, the file system on VMS is totally different from the one on Unix, like the ones that, and it's not POSIX at all. It wasn't back then.
When was that? If you don't mind admitting.
So it was at that time was VMS.
Yeah, yeah.
And it was 1995.
Right. Okay. Yeah, a long time ago. Okay. So one of the good things that VMS engineering did subsequent to 1995 is they have actually built a reasonable level of POSIX compliance into the C runtime library. So if I specify a file path, I can actually specify it in Unix, Linux syntax. Okay? I don't have to specify it in what you would remember as the VMS file syntax. If I'd had to do that, this would have been an absolute nightmare. And I probably would have just thrown my hands up in horror. So no, it is possible on VMS with some minor restrictions to specify paths as using Unix syntax. Yeah.
Thank you. Very fun and interesting. You mentioned several times about trying to get younger developers interested in working in this sort of area and explained why we would want people doing that. But if younger people did want to play with it, how would they get started? Because I don't have a mainframe at home.
No, and that's no. Most people don't have a mainframe at home. I do have a colleague who probably does, but he's strange. No, exactly. He's an absolutely lovely guy and quite a genius. But you're quite right. Most people do not have a mainframe stashed away in the back cupboard or the basement. We, as in the 21st century side of the business, who do most of the mainframe development, have offices in I forget which city it is in Germany, but in Perth, Australia, and a few other locations, definitely in the US. And they actually hold quite regular, I'll call them meetups, but they're probably a bit more than that. And it is quite interesting to see that they are getting an increasing number of younger people coming along to those. You know, you just provide the right environment, and it seems to work. And I don't, you know, it's funny, like our old VMS guys, well, I'm one of them, but we're all replaceable, right? You just got to mentor these younger people, you've got to keep them interested, you've got to keep them motivated. I had we've got a team in Armenia, absolutely stunningly good developers, really, really good. But they're really abstracted from the customers, you know, and one of the things I've discovered that they really like to know is they like to understand the work they're doing, how does that actually relate to, you know, the other end, to the customer. So, you know, don't just treat them as a pile of engineers, make sure they actually understand why you're asking them to do what they're doing. But I think if you provide the tools and you communicate properly, I don't think it's a big deal. Yeah.
Thank you.
Amazing. Maybe a question from me. Did these changes make it all into the OTP mainline?
No, I think most of them would be rejected in the state they're currently in. But like I said, you know, now that we've got the OpenVMS operating system working well on x86, which actually gets us into a lot better shape, I can probably rip out a fair number of them, which I think may make it far more amenable to slipping it in there. But don't quote me on that. I need to do some revision.
Sounds amazing. Thank you so much.
Okay. Thank you.